Okay, so let's look at this problem. Very similar, except again, we don't have this exponential piece isolated. So to get this piece by itself, the 4b, 4 to the b power, we need to get rid of that 5. Right now it's getting multiplied, so the opposite of multiplying is dividing. That leaves me with 4 to the b power equals 8 over 5. Now I have that exponential piece isolated. So I look, can I write these as the same base? The answer is unfortunately no. I can write 4 as base 2 and 8 as base 2, but there's no way to write 5 as base 2. So I have to move on. So what I'm going to do is take the logarithms of both sides so I can get that b out of the exponent. So log of 4 to the b power equals the log of 8 over 5. Now I did keep this as a fraction because you don't want to reduce anything or simplify by approximating, by plugging anything into your calculator until the very end, because if you're off by just a few decimal points here, you can end up by being off by a lot later. So you always want to approximate at the very, very end. That is your last step. Keep things exact until the very end. So again, now that I have this, I've done the logarithm to both sides, I can use that power property to move that b in front. And now I just have b times the logarithm of 4, which is just a number, equals the logarithm of 8/5, which is another number. So to get the b by itself, divide both sides by log of 4. And you get the exact answer for b is the log of 8/5 over the log of 4. And if you were asked to approximate this answer, you would put that into your calculator, and you would get that that's about 0.34. All right, let's look at this problem. 2 to the x minus 1 equals 5 to the 2x plus 3. So this one's about as complicated as it's going to get, and it's really not that bad if you just go super slowly and think things through. So in this case, I actually have two different exponential pieces, and both of them are already isolated. So I'm going to take the logarithm of both sides to get those x values by themselves, or I can move them as factors. All right, so taking the logarithm of both sides. So that's going to allow me to move this x minus 1 in front. And now remember that this is the entire quantity x minus 1 that is moving in front. All right. Now, I need to get these x's, the x, isolated because I'm trying to solve for x. Right now it's stuck inside those parentheses. So what I'm going to do is distribute it through. So I get x times the log of 2 minus 1 times the log of 2 equals 2x times the log of 5 plus 3 times the log of 5. Okay, so I have two different terms that have x values in them. I'm solving for x, so let's get all of the x values on one side and anything that doesn't have an x value on the other side. So what I'm going to do is I'm going to subtract this 2x value to both sides. So that's going to leave me with x log 2 minus 2x log 5 on this side. And I'm going to add this log base 2 to the other side so that I can get rid of it on the left. So 3 log 5 plus log of 2. So again, I subtracted this from both sides, so that left me with 3 log 5 on the right. And then I added this to both sides, so that left me with just this x log 2 on the left. Okay, so I got all of the x terms onto the left, all of the non-x terms or the constants on the right. So now you can see that these have in common an x, so I'm going to factor an x out. When I do that, this leaves me with log 2 minus 2 log 5. And you can see these are the same things. If I distributed this x through, I would get this line. And by doing that, that's allowing me to get this x isolated. I have x times this nastiness. So to undo a multiplication, you divide. So this is exactly 3 log 5 plus log 2 over log 2 minus 2 log 5. So there's the exact answer. That is really ugly. And then if you were to approximate it, it's about negative 2.19. Now you will have 1 or 2 of these for the homework, and I will tell you that something like this could show up on an exam. So make sure that you are practicing these. If you need more, feel free to send me an email and I can take you to some more spots where you'd find things like this. But again, it's the same process. Get the exponential pieces by themselves, take the logarithm of both sides, isolate the variable. So I took all the terms that had x's in them, brought them to one side. Any term that didn't have an x, brought it to the other side. And then I factored that x out so I could isolate it by itself. Now there's some equations that you actually aren't going to be able to solve by using any of the methods before. And to do that, you can solve by graphing. So for example, looking at this one equation, e to the x equals negative x, and you can solve it using a graphing utility. I'm going to show you guys how to use this on Desmos because in my opinion, this is the fastest. This is also the easiest to use. You're also more than welcome to use your calculator for it, and I have links on how to use the different calculators to do this specific thing on our resource widget on the homepage of our website in D2L. Now, please note that I'm not going to be asking you to do this on an exam, but it is important that you do know how to do this using Desmos or your technology using your calculator, whichever one you're the most comfortable with, just for future math classes and also for doing the homework. So if you prefer Desmos, just learn how to use it on Desmos. If we had to solve this, what we're going to do is we're trying to figure out what values are going to be equivalent on either side, what value of x. So what I usually do is I graph the left-hand side, so y equals e to the x. The left-hand side of the equation is one graph. And then I do another graph. So we'll graph y equals the right-hand side, which is negative x. And when you do that, you can see where these end up crossing each other. And I usually try to zoom in and zoom out just to make sure I don't have any more pieces that they cross. And it looks like it's only at that one spot. So with Desmos, when you click on one of the lines, it'll bring up the interesting points, and you can see this point right here is the interesting point. So the x value, this point right here, the x value of that point where both of these lines intersect each other is negative 0.567. So that is the solution. So the value of x where both of these have the same value of y, so where both of these are equivalent, is x equals negative 0.567. So that would be the answer to it. So again, when solving these by graphing, graph the left-hand side of the equation, graph the right-hand side, find the point of intersection, and that x value is the solution to the equation.